Hello, everyone. Welcome back to a wonderful Wednesday. I don't actually know if your Wednesday is wonderful. It's pretty chilly here. I think it's warmed up. Last night it got a little chilly, but it's sunny. At least here it is. Hello, Saida. How are you? We got snow. How much snow do we get? I looked at the forecast. I don't think it was supposed to snow. Hey. Welcome, everyone. Welcome. My dad went to the store. I'm not sure I've commented on these. I don't think is it? Yeah, this side doesn't have any text on it. 50 car pileup? Because of the snow? That's not good. Wait, I gotta see this. Hold on. Oh my gosh. Oh my, wow. That's crazy. That is absolutely insane. Okay, well. So maybe it's not a great Wednesday. But it is you know what it is? It's a great day for a day to be a Wednesday. That's just a Wednesday thing to happen. You know, you're like, "Oh, pretty, smash." Wednesday is like, I feel like it's a fake optimistic day. You know, people are like, "Oh, it's hump day." Yeah. But at the start of hump day, you're not actually halfway. It's like fake optimism. I don't know. I guess it is coming up on noon, so maybe it'll be middle of the week soon. Oh. Okay, nice. It's your day off. That feels good. So then does that make it the end of your week? Or do you think of your day off as the start of your week? Start of your week. Okay, respect that. I like that. I've been thinking about this recently, actually. Do I prefer to think about, so that we call Saturdays and Sundays what? The week end. That's their name, right? We call those days together the week end. But what if we called it the week start? And we thought about Saturday and Sunday, our presumed time off. Of course, that's a pretty flexible idea. But, the non-business days, what if those were the week start? Does that change how I would view my work? Starting with time off, or is it better to think of the weekend as like, the light at, not the light at the end of the tunnel? That's so doom and gloom, but does that change my, the way I think about my days at work? I don't know. I don't really think so, but it was an interesting line of reasoning. But anyway, I didn't finish saying, so I guess you can't actually see it, so I guess I don't need to comment on it. But my dad went to this pottery store and bought a whole bunch of $2 coffee mugs. And some of them say groom, and some of them say bride on it. And that makes me laugh. Why did he do this, by the way? Because he liked the shape. And you know what? That's what coffee's for. So I guess you don't have to have any meaning. Yeah. Unfortunately not. So, a bit, yeah. Anyway. So, it's just kind of funny. Like, Dad, what were you doing? I don't know. He's happy. That's what matters. All right, let's get to our announcements. Let's get into it. I've kind of stalled for a few minutes chatting, saying hello as we wait for people to show up. I have a song in my head, and it's really not going away. It's a funny song to me because I think I just messed up my Zoom. Yeah. It's a funny song to me because the singer is about how, like, basically it's like guys think girls are wusses, like are weak or whatever, and she can keep up with the guys about, like, drinking and smoking and whatever. And then recently she got arrested for something like kind of similar. It's like, well, good job. You proved your point. You did it. Like the singer. It's like awkward. Very unfortunate. Okay. So, really not a whole lot new here. Just kind of reminders, University Climate Study. Chapter 7, which we're going to finish up. Today, we skipped the finite populations part and population proportions part. And Chapter 8, which we'll start after we finish Chapter 7, we'll just skip population proportions. So I'll kind of keep this list. I'll add Chapter 9 as we get there, and I decide what we're going to cut out. And then we'll just keep working our way through these things in the next few days. Because, of course, we are almost done with this semester. Almost done. We only have a couple more class periods left. So another reminder, since I won't see you again until this, Chapter 7 Mind Tap homework assignment will be due Sunday, 4/19 at midnight, which I have not actually posted for you yet. So I have to post that, which let me make sure I don't forget to do that. So, I forgot. Isn't this a cool wallpaper though, by the way? Check this out. While I mess with this instructor dashboard thing. You can't open your Cengage and the free trial is gone. They're just going to be difficult, aren't they? Same. Okay. Well, looks like I got to call somebody and do some leaning, if you know what I mean. Okay. No, I haven't. I need to cut down the question lists, and I have not had time. Okay. New email. Subject. Pulls. Fix. Cengage. That's not what the actual subject line is going to be. I'm just going to, that will remind me what the message was about. Okay. Well, they assured us that they would let you redo the trial, so I'll see what has to be done, and I'll get back to you. Obviously, if you can't do it, I can't make you do it, and when we do, we'll figure it out. I'm not gonna hold you hostage. Oh, not F12, F11. Ah, yes, function keys, very important to push the right ones. Okay, so Mind Tap homework assignment, gotta work on that 14-day trial. Chapter 7, vocab quiz today. Based on reduced list of words on D2L, I posted a list of words. Hopefully you saw those on D2L, where I told you I posted them down here. Where was it? Content, links to online learning resources. Yeah, that's the one. Okay, and we'll have one quiz, one new class assignment. Possibly one of them will be on Wednesday of next week. Otherwise, they'll both be on Monday of the following week. So, like the 27th, Monday the 27th. But we'll see. I'll let you know. That's a little bit off for the moment, so we will. So if we did the quiz, it would basically be over Chapter 7 and 8, but you won't have seen half of Chapter 8 until Monday, so that seems pretty rushed. But I don't necessarily want to do 2 different assignments in one day, although it kind of has advantages. So, yeah, I don't know. I'll think about it. Okay, that's it for announcements. Not a whole lot new, mostly because I gave you a lot to think about last time, so there's not a reason to cover much in the way of new stuff. So, let's just get to our first order. I can say it. I can do it. First order of business, which is our vocab quiz. Let me talk about something. I didn't put this on the announcement slide. Maybe I should have, but I've been tinkering with the grade book for what I can do with these exams, because the way that the grade book system works has some flaws, and it will not let me just make a new column that adds together the 5 exams, which to me is silly. I'm not sure why that's not possible. Or, well, rather you can, but it has to be its own category. I cannot make an exam 2 score, put it in the exams category, and then have it just add the 5 columns together. Why? As far as I know, there's no reason, but they just don't let you do it, which is kind of triggering. Makes me really freaking upset, but breathe through it. Okay, really drives me crazy, but because I just can't understand why they put that restriction. You had an error with one part of the exam. I would love to talk to you about that, but not during class. We can talk about after class or before class, or email me or something. There is a question that I will be taking out. I'm not sure if that's what you mean. I forget which part it was in. I think it was in part 4. No, part 3. I think it was in part 3. I'll have to go back and look. But there is a question I'm taking out, but I haven't done it yet. Anyway, so the point, what I can do, so this is what I can't do and what I can do, meaning your quiz grade. I thought they were there. I can go back and look. I did forget to connect the, I forgot to check the box that automatically exports grades from part 4 of the exam, but that has been remedied. So it is there now. Oh, it's sorted by my last name. I was like, Bart, you're not here. Looking at the last names. Woo! It's amazing how much difference that makes. Okay. Okay, so you think you got some right answers wrong. Remind me later. I'll take a look at it. We're not gonna take the time to do it right now. Actually, I guess we can do it while I send you guys another vocabulary quiz. Oh no, I named them in an inconsistent format. 1 second. Okay. Very important. Okay, so did I finish saying this? No, I did not. Okay. These 5 exam portions are separately listed, but I cannot combine them automatically, so I'm going to have to combine them manually. And so I think I put in the grade column. I might have taken it out or put it back in. I tried several versions of this, so I can't remember what I actually have in the grade book at the moment. But what I will do, I know I've got a couple people who had issues, so I just got an email from one of you. I got the notification on my screen. I glanced at it. I'm not sure who it was. I know a couple of you had some issues that I still need to iron out, so I have not put up the final scores into one big column because, well, A, I've got to take that question out, and B, I know there's a couple of things that we're still tweaking. So for the scores that are in there, they're largely correct, other than that one question, which will make your lives better. I think it's on part 3, and then I'll put it all into one column to go into the exams category, so that at the end of the semester the dropped exam will work properly. So I'll try to finalize that and let you know. Okay, but first let's do a vocab quiz. Okay, so I'm going to make it available to you. You have 15 minutes as usual. Right now it is 11:45. Make it available an extra couple minutes, but it's going to break whenever I click this button. Okay. 1 minute. Okay. Prevent the student from making further changes. Okay. So, quiz is available. So, good luck on your vocab quiz. I'll take a look at Bart's quiz on my other monitor. Is the quiz through lockdown? No. So as you can see here, this required lockdown, this does not. Not everyone can use the lockdown browser, unfortunately. Okay. You can look at another beautiful wallpaper. I have my wallpapers shuffle every 10 minutes. So I've got a bunch of them. So you'll see different things pop up in the background. Some from TV shows and things. So if you've seen them and want to talk about them. Okay, I'm going to mute my desktop sounds in case people send messages and stuff so that you don't hear the dinging. Okay, and I will be quiet for the next few minutes. Okay, folks, we got about 2 minutes left, so if you haven't finished your quiz, please get that done. 2 minutes, and we're going to move on. Cat hair. There are so many. Okay, it's that time, everyone. So we'll move on. Bart, like I just said in the chat, I have it put in under the question feedback. So you may have to go into the quiz itself. I'm not sure. I've never used these types of questions before. Last week, whenever we did the first one, so I'm not entirely sure how the feedback displays. So when you find it, let me know, so I know how you found it. Just while I have this pulled up, just for fun, I have a big group of wallpapers. I don't know how many this is. Does it tell me? 79 wallpapers, from nature and video games and anime and movies and some abstract stuff, encouraging statements, things like this. Unfortunately, some of them are intended to be viewed on both monitors at once, like, for example, this Assassin's Creed background, which, just as an example, it's really, really widescreen. So it's intended to be viewed on two displays. So you might see only, this part and to the left, which really kind of lessens the impact, but oh well. Sorry. Nothing I can do. Okay. I actually don't think I have any Disney wallpapers. I'm open to suggestions. I have not been maintaining this folder because I have three monitors at home. So I use a different set of wallpapers when I'm in my office in Chicago. So I have a wallpapers folder, and then inside of my wallpapers, I have all my single monitor wallpapers, and then I have two monitor wallpapers, which is the one that I'm using right now. Oh wait, I do, because I have some. Oh no, I do. Disney. See, it's Disney now. That might be it though. I've got Skyrim, if that counts for anything. A couple Skyrim posters, some One Punch Man, Ruby. Oh, more Disney. Got some Disney. No, I haven't. I've heard it's good though. Okay. This is my very Manilow voice. The test question? You mean the one that I'm throwing out? I suppose I can. I'm not entirely sure the question has a right answer. because there was a typo in the question. The question was asked in one format on a previous exam, and then I changed the question for this exam. So when I gave the exam last year, I asked a similar question, but I changed it for this exam. Unfortunately, I didn't change it entirely enough, meaning I missed something I needed to change for it to all make sense and then to be a holistically correct new question. So there was, in other words, there was a remnant of the old question still in the new one, which means that it was kind of unanswerable. I can stop and think about if there's a way to work backwards and kind of figure out you weren't intended to do anything nearly as complicated as what you would have had to try to do. And I know some students attempted it, but I'm pretty sure they didn't get the right answer. I'm not entirely sure that it is possible to work backwards and get a correct answer. Even making your own set of assumptions. So I'll have to look. A question that converted centimeters to inches. I didn't do that on purpose. If I did, would probably know. But I guess maybe. The one with the tree. No, it was the one of the binomial questions. All right, let's talk about Chapter 7. Okay, so last time we selected a sample. We did point estimation. We introduced sampling distributions. And now we're going to talk about sampling methods. That actually doesn't feel very good. I'm not going to keep doing that. Okay. Slide 54. Let me get the scene moved over. All right, get my head out the way. Move, head. Get out the way. Get out the way. Of old Dan Tucker. We can just pivot this in all kinds of crazy directions. Okay, so we talked a little bit about sampling, the idea of simple random sampling, where you just kind of pull stuff, and then hopefully it's going to work out because you pulled things randomly. And so there's no chance that you bias yourself because you took things randomly. There are some other sampling methods that we're going to discuss. These 5: stratified random sampling, cluster sampling, systematic sampling, convenience sampling, and judgment sampling, which might sound familiar if you studied your vocabulary words. And one of these appeared on the quiz. So hopefully that sounds familiar. Okay, so for stratified random sampling, the first thing we do, we take our population and divide it into groups called strata. So stratified just means like separated and grouped. So we break our population into groups, and the idea, of course, is that we don't have any people who are like in 2 groups at once. You're in a group, you're in one group, you're in exactly one group. No more, no less. One group. Now, if we do a really good job, this will get the best results if we group each of the people with other similar people, meaning that each of the people within a given stratum are as much alike as possible, which we call a homogeneous group. So homogeneous groups will produce a better outcome than non-homogeneous groups. And then what we do is once we have a group of stratum, so the idea is that we've kind of said like, okay, so we've got a series of groups in the population, and then we want to make sure we are capturing each of those groups. And so maybe, for example, you would use, like we're trying to sample college students, and we know that there's a distinction between freshmen, sophomore, juniors, and seniors in terms of their standing, just in terms of like how many hours they had. I did forget to turn the desktop audio back on. Okay, so desktop audio should be there. Is that true for everybody? I can turn the monitor on and just check it. Someone tell me if it's... not that one. Hear me fine? Okay, try refreshing. Oh, sorry, my nose is tickling. My cat comes and like sits in the chair next to me or whatever, and so I have allergies just floating in the air everywhere. I love him, but he makes me sneeze. Okay, so imagine we had our 4 groups of students: freshman standing, sophomore standing, junior standing, senior standing, and then we're going to sample from each of those. So in this case, we would take a simple random sample of each of the 4 years, and then combine the simple random samples together. Don't have them. There we go. Okay, so there are ways of combining the strata sample results into one parameter estimate. We're not going to worry about it in this class right now. I just want you to know that it exists. That's a thing you can do. The goal is, by the way, to have as good, as precise, as representative, as whatever, of simple random sampling, but with a smaller total sample size. So you do a little bit more work up front to group your in this case students, but group your population members. But then you have a smaller sample size, which makes the rest of your analysis easier. But of course, if you don't do a very good job with your strata creation, then you might cause yourself more problems. A similar approach, but with one very important difference, is cluster sampling. So again, we're dividing our population into groups, but as opposed to strata, where we are intentionally creating one consistent type of person. In this case, it was freshmen. Which of course is not going to be holistically representative of all freshmen are the same. Obviously not. But that tells us something about them. Whereas if we don't bias it at all, we just choose a total random sample. We don't know anything about it. And so if year in college is worth something to us, then we're going to have to capture that with randomness, which is going to take us more sampling to make sure we have represented. Cluster sampling, on the other hand, does the opposite. Instead of trying to create homogeneous groups, we're actually trying to create heterogeneous groups. We're trying to create small-scale, miniature versions of each population into a bunch of different clusters. So it's sort of like, rather than taking a bag of M&Ms and separating them into all the different colors, instead, we take a bag of M&Ms, we empty it out, and then we try and have the same number of each color in each of the groups. We make a whole bunch of handfuls. I don't know why you would do that, but maybe you could. It would be a strange thing to do, but it's possible. So the reason we do this is because we can then simply take a random sample of the clusters themselves. And so our sampling, we only have to sample like 5 or something. Or a small number, and then we just group all of our elements in that way. We take everything in the cluster if the cluster is chosen. So why would we do this? Well, usually we wouldn't. Not intentionally. We wouldn't take a regular, a regular population and just try to clump it together and make heterogeneous groups. And the reason you wouldn't do that is because if you already knew how to group your population into heterogeneous groups, you would probably not need to sample. If you knew that much about your population, then you probably wouldn't need to bother with your sample. You already know it so well that you can make estimates for your population parameters and call it a day. However, there are times when your population has some kind of characteristic that sort of lends itself to clusters. And the most obvious example is area sampling, which is like if you have clusters defined by a city block or like maybe a county or some kind of really well-defined like geopolitical marker, then it's really easy to say like, okay, when I say political, I don't mean like your political leaning. I mean like what voting precinct are you in? There's all those there's thousands of them in a single state potentially. So you can use those districts, or you can use a block, or you can use something like that, which is very well defined. And actually, voting districts are a horrible example because of what's the name, gerrymandering? Is that the name? Those voting districts don't make any sense at all. They are intentionally chosen to skew the votes. So they would be a really bad thing to use for gerrymandering, right? Yeah. It's a really bad thing to use for cluster sampling. So I wasn't thinking about the fact that it's the construction method. So actually that raises a really good point. So that this is the danger of cluster sampling, is if you think that something is a good representation of your population, you'd better be really sure, because In the case of gerrymandering, it's not. They are chosen and to skew. They are literally chosen to be the opposite of what you want for cluster sampling. Instead of being as reasonable representation of the population as possible, the whole point of gerrymandering is to carve out parts of the population. So yeah, horrible. Don't use that. But the whole point of this is actually a great idea. It's a great thing to bring up, which I did on accident. So yay me. The point is, be very, very careful about your clusters. And there is an inherent risk here, even if you use something that's as innocuous as a city block. Of course, if you compare one city block to another, you may have lots of differences in your socioeconomic status or, different cultural backgrounds. And not to say one culture is good or bad, but they're different. And so if you're testing for something, maybe one culture values it, another culture doesn't. Or one culture values something else that's a stand-in, it works just as well in their lives, but yet it doesn't show up on your test or something. So you've always got to be really, really, really careful with cluster sampling, or really, kind of any sampling ever at all. But there's some big disadvantages here. So yeah, this is convenient. The close proximity of elements makes it cost effective. You just stick somebody on the corner of the block and with the clipboard and just knock out a bunch of observations. So you can probably get a lot of data cheaply. But you need a lot of data because there's inherent risks, there's inherent ambiguity, there's inherent bias in this kind of sampling. So you're going to need a larger total sample size than simple or stratified sampling. So, big advantages, big disadvantages, big ups and downs. Systematic sampling is probably the simplest, although at the same time it's almost like maybe the hardest to explain. Because we have this formula here that may be a little opaque for some students. We might sample one element for every n over n elements, little n over big N. So basically, we're desiring a sample size of something, 10, maybe 100. That's little n. From a population, which is going to be much bigger, 1,000, 100,000 or something. And so we might sample, to get our sample size of 100, we sample every one out of something. Elements in the population. So for an easy example, suppose that we had a sample size that we wanted of 100 out of a population of 1,000. So how many is that? 100 out of 1,000. Well, 100 divided by 1,000 is 1/10. So if we want to pull 1/10 of the data values in the population, of the elements in the population. So what we do is we just list all of the items in the population, and then we sample one, every, in this case, 10th, one. Whatever your n divided by n works out to be, you sample every one out of that many. So that every 10th one, every 15th one, every 20th one. So, maybe you're talking about, I want to sample customers at Starbucks or something once the quarantine's over. And so you just stand at the doorway, and every 10th person who walks through, you say, hey, can I buy you a coffee? I need to ask you some questions for, this sample, or something like that. Or you just grab them and you're like, hey, do you have a minute to talk about our Lord and Savior Jesus? Whatever you're doing. I feel like that could be a hot topic right now. Scary times. Anyway, point is that you randomly pick one of the first handful, and then you just repeat the same interval. So like, okay, I'm going to pick somebody out of the first 10, and then I'll pick every 10th one from there. So, it's easy. You could be like, hey, every 100th listing in a telephone book or something. I don't know. Just list them. It's not complicated. So the good news is that this has all the properties of a simple random sample, especially if the list of the population is random. I would argue that alphabetical ordering is not random. There's going to be biases based on cultural preferences in spelling, or cultural tendencies in spelling. So that's not going to be actually a good method for alphabetical ordering. So generally, your sample is easier to identify, which especially if you don't have a computer or a digital database, this is a really good way to go, but it can introduce bias. So can be just having downsides. Okay, last two. So last two are non-probabilistic. So the previous ones were probabilistic. These are non-probability sampling techniques, which basically means that we're including items in the database without knowing the probabilities they had of being selected. And the name is very self-explanatory. This sample is identified by convenience. I've given you several examples of these and the dangers with which it is fraught. For example, a professor conducting research using student volunteers, using the students around him at his university or her university, because it's convenient, because it's easy. That might have a lot of problems. So I've talked about this at length. I won't keep on it. It's easy, but you have no idea how good your sample is. Yeah, that's long and short of it. Okay, this one's more common than you might think. The judgment sampling, which is basically you ask somebody who's really knowledgeable, and they select the elements of the population that A feels are most representative of the population. So this is obviously non-probabilistic. So this happens a lot actually in politics or something. A reporter will so you have people. Some reporters are like really specialized, like, oh, I do, specifically reporting on one major topic as it relates to the Senate or something like that. And so in that case, a reporter would have a really good idea of how those senators tend to vote, how they think, and how they feel on a topic. And so that reporter would probably have a good idea of which handful of senators would speak for, the population of senators in general, especially given how often you have voting down party lines, or you have like leadership within the party, because we have a two-party system largely. So often you can ask just two representatives of the party, and they will give you like, here's what our party is voting, and then you've got a pretty good idea of what that is going to be. Now, there's dissenting votes, usually, and often if I hear that there isn't a dissenting vote, meaning there are no dissenting votes, we voted down party lines, I'm upset because something has gone wrong. It's the Senate. There's 100 people. You're telling me you can't convince. It's about a 50-50 split, close. It changes from year to year, but you couldn't convince 1 out of 50 people that your idea was good. So either the proposal sucks, or people are just squashing it for politics, political reasons. And that irritates me. So anyway, it's relatively easy, but it depends entirely on the judgment of the person selecting the sample. So pros and cons. So in general, we recommend that you use probabilistic sampling methods, meaning simple random, stratified, cluster, or systematic, because we have formulas. We can actually establish mathematically the goodness of fit, is what it's called, the goodness of the sample results in terms of how close they are to the results of the population. If you don't have probabilistic methods, there's nothing you can do. There's no evaluation of the goodness that you can make for non-probability methods, convenience and judgment. And so you're just whipping it out there and hoping for the best. Which, if you want to be biased, if you want to just say whatever you want, then that's a good thing to do, However, if that is your approach to things, I've got a problem with that. Make data-informed decisions, please. Especially if any of you go into politics. I will write your mother a letter. I will find your address. I will. And then I'll find your mother's address, and I will send her a very strongly worded letter about how her child turned out. You don't want that. So use good data, or I'll tell your mother. The ultimate is if I can take your seat at the Thanksgiving dinner table. That'll be my goal. I vow this. Okay, so that is all she wrote for Chapter 7, other than the parts we skipped. So let's spend the last few minutes getting into Chapter 8. So what did we do in Chapter 7? Little recap. Oh, man, I'm coming at you. Yeah. Look, just be thankful I don't have a tiger and some whatever oil or whatever that was. That's all I'm saying. For the FBI agent, or the NSA? NSA is that's the domestic threats, right? I don't remember which one's which. Whatever, to the agent who's watching this video, that's a joke. For legal reasons, that's a joke. It's entirely a joke, actually. I'm just trying to stay current, Okay, so Chapter 7. Chapter 7 was all about samples and point estimation. So again, we're building a pyramid here. We started out with the very base, which is data. How do we get data, sample data, into a usable form? And then we start out by making an estimate as to the value of some population parameter. We say, okay, this is what we think the population parameter is. And now we are going to start adding in a prediction for how wrong we might be. So we'll start with the easiest circumstance, which is if we know the population standard deviation, and then we'll talk about the adjustments that have to be made if we don't know. And then we can use this information to determine the sample size, which depending on how far we get on Monday, we may cut that part. Hopefully we don't have to, though. So after all, we cannot expect our point estimator to provide the exact value of the population parameter. We might get really, really close, but it's not going to be perfect. So we can compute what we call an interval estimate by adding or subtracting some margin of error to the point estimate, right? And I mentioned this last time. You've probably seen this in the news. You've seen this in reports, newspaper maybe, where they say like or you'll see like survey data, like, oh, the number of people who live in Scandinavia. Oh, finally. That's been tickling me for like half an hour. The number of people who live in Scandinavia is approximately, 30 million plus or minus 20,000. Right? You'll see this like an estimate plus or minus some amount of wiggle room that we think is maybe how far we're off, basically. And so we have, that's the format we have here. Estimate plus or minus the margin of error, or as I call it, the wiggle room. And of course, the idea here is to provide some information about how close we are to the real value. Because it's quite a different thing to say like, oh, out of 30 million, we think we're off by 10,000. Oh, okay, well, that's, not even a percent, right? That's pretty small. That's very precise. Whereas if you say, we believe the population is 30,000 or 10,000 with a plus or minus of 30 million. So there's quite a good chance that it's actually zero. We have no idea. Obviously, there's not a negative population, right? There aren't people like inverted, exploding, hopefully. I'm not talking about war. I mean like imploding, I should say. Not exploding, imploding. Not possible. So probably zero people. So it's very important, the relationship between the size of your point estimate and your margin of error. So there is this general form. We have a point estimate, which we'll use for the sake of a population mean, is X bar. So same idea, right? This is just point estimate, margin of error, right? Point estimate, margin of error. So if we're using a particular point estimate, the population mean, then we can use the particular variable, the symbol, X bar plus or minus the margin of error. So this is what we're going to do, is we're going to create expressions like this. And then we'll extend this to its conclusion in chapter 9. Okay. So, in order to develop an interval estimate of a population mean, then we have to compute the margin of error. How do we know our margin of error? Well, it depends entirely on the amount of variation in the population. So ideally, we'll simply know the population standard deviation, sigma. That's right here. If we know this, that's what we call the sigma known case, then great. We have a very good idea of how much variation we could be missing. But if we don't know the population standard deviation, then we can use the sample standard deviation, which we know is related, of course, to the population standard deviation. And so we can use the sample standard deviation to give us a less specific estimate. So it's an option. Now, of course, hopefully your red flags are going up, and you're saying, Rob, if I knew the population standard deviation, I wouldn't need to do the sample. I would already know other things about the population. Well, That's true. That's just true. We pretty much don't ever know for precisely the population variance, but historical data is actually pretty reliable. It is generally the case that variation in processes changes much slower than the process of the center of a process. So while the actual value of your point estimate will change, the mean will change, the standard deviation will stay the same, or at least pretty close. So we can get a pretty reliably good estimate from historical data or other information. So if we actually do have these this good estimate, then we can use this as the sigma known case and follow the approaches we're about to discuss. Okay, now, in the book, it goes straight on to discuss the next topic, but I think if we start here with this sort of, I called it a brain teaser, but I want to start building intuition, meaning I want you to start thinking about these kinds of problems and building pathways in your brain about these ways of thinking, and then I'll tell you the theory that this is connected to. I think this is easier to learn. Okay. Brain teaser, thought-provoking question. Think about normal distributions. If I were interested in finding the middle 95% of data, what probability would I use to look up our z-score? Okay, so if you remember, anytime we're looking for a middle value, we talked about it last class. You draw your picture, and then you draw the lines where you are interested in, here's the lower point, here's the upper point. You look up your z values, which of course you have to get there from your x values. So you convert x to z's, look them up on the probability table, on the z table, the probability distribution table, and then you subtract the little one from the big one, right? Well, it just so happens that anytime that you have your interval is centered on the population mean, then the z value you look up on this side will be the negative form of the z value you look up on this side. And the reason is it's a symmetrical distribution. So if you have a symmetrical interval, then the amount on both ends will be the same proportion. Right? This distribution is symmetric. So if I have 95% in the middle, let me start with this. Go ahead and put it in the chat for me. If I have 95% in the lighter blue area, then when I combine these two pieces, what do I have left over? If this is 95%, what do I have left over? Go ahead and put it in the chat for me. Absolutely, guys. That's absolutely right. 5%. Why? Because the total thing is 100%. So if I have 95% in part A, then part B has to hold the remaining 5%. And because I know that these 5% is broken evenly into two pieces, then of course you just divide 5 by 2, which is 2.5, or in this case, 2.5%. So that means that there's 0.025 over here, 0.025 over here. And so I can look up for this z value, I know this is 0.025 on the probability portion of the table, which admittedly, because we kind of rushed through things, we didn't spend as much time, especially not last chapter, but even in chapter 6, we went through it quickly. We didn't talk very much about working backwards, which is looking up probabilities and using that to find z-scores. But it's an algebraic reversal, right? You just go the other direction through the process, and you can look up z values, and then you use your z value to find x values. So here's the math. You said it. You got it. Maybe you guys cheated, and you went to the next slide. But hey, you used the tools and the resources that you had available to you. So I call that resourceful. It's not cheating in this case. It is if you use an unauthorized resource in an exam. That is exactly what cheating is. But this isn't an exam. It's not graded. So yeah, good for you. Good on you, mate. All right. So now I've never really understood I'm going to kind of do. I feel like this is an annoying way to call it this way, but there's a reason. It just irritates me. I just need to get over it, I think. I think this is one thing I need to get over. I've been upset about it for years. I need to move on. I need to find closure. The statement is, there is a 1 minus alpha. If you don't know the Greek, that is alpha. That is a lowercase a, alpha. Or it's equivalent to an a, lowercase alpha. There is a 1 minus alpha probability that the value of a sample mean will provide a margin of error of z subscripted alpha over 2 times sigma subscript x bar, or less. Okay. There's a lot to unpack there. All right, so let's just start at the top. So 1 minus alpha. So if you're looking for probabilities, we usually want big numbers for probabilities. We want to be confident in whatever we're saying. The standard answer, the one that I just kind of suggested to you a moment ago, is 95%. So we're going to use 95% for, that's a good probability for a margin of error. So if we use 95%, there is a 0.95 probability, then what is alpha? So in other words, I'm going to put this in the chat. So what would be if 0.95 equals 1 minus alpha? What is alpha? What is alpha? Well, we move the alpha to the left side and we subtract 0.95. So, what's left over? Yeah, there's 5%, right? Which, hey, that was my brain teaser. That's exactly what we are doing for alpha. We compute alpha in the exact same method for the exact same reasons that I proposed in the brain teaser, which is why I've done it this way. So we get our 95%. So the same picture basically, but with a whole bunch of extra stuff on the screen. I'm going to hide this in a second, but I just want to point out this is the 1 minus alpha of all the x bar values. Okay, now hide the picture. Okay, that is the probability portion. Now let's look at this intimidating margin of error thing. Z of alpha over 2 times sigma x bar. Okay, so Z alpha over 2, that just means, so we computed alpha a moment ago, right? We said 1 minus alpha equals 0.95, so therefore alpha equals 0.05. Okay, alpha equals 0.05. I've got that. In fact, I'm going to write it to the side because now we've established alpha equals 0.95. Okay, alpha equals 0.95. I'm sorry, 0.05. I'm going to erase that while we're at it. Come on, here, boy. Equals 0.05. Yes, alpha equals 0.05. Okay, so therefore, what is alpha over 2? 0.05 divided by 2. That's the 0.025, the 2.5% that we computed for the outsides. So, again, my example problem is hopefully making this all make more sense. So then, Z of alpha over 2 is just a fancy way of saying what is the Z value that corresponds to this little piece if the middle is the big piece. So whatever this number is, subtract it from 1. That'll give you 0.05 in this case. And then divide that number by 2 and look up that probability on the Z table. Z of 1 minus alpha divided by 2. That's how we get this. That is the whole idea of Z alpha over 2. And then this number, this Z, which I believe is 1.645 is the Z value, if memory serves. This number is multiplied by sigma x bar, which remember we talked about sigma x bar last time. Sigma x bar is the standard deviation of the sampling distribution, which we will compute directly from the sigma of the population because we're assuming that we know it. That's what the sigma known case means. So that means we have our margin of error of z alpha over 2 sigma x bar, which is, again, that's going to be added or subtracted from our x bar, which means that this interval here is defined by mu, or our estimate for mu, x bar, plus or minus z alpha over 2 sigma x bar. Okay. 1.96. Okay, it's 1.645 if you're looking, that's the 95% percentile. It's 1.96 if you're using alpha over 2. So, very important. Okay, so if you look it up on the table, you'll get 0.025 will give you negative 1.96. So your interval estimate is mu plus or minus, or I guess it's x bar plus or minus 1.96 sigma x bar. Okay. Now, the interesting thing is that there are a lot of possibilities. I know we're running out of time, but there are a lot of possibilities, right? Our x bar can fall anywhere within this entire number line, right? It doesn't have to be in here. It's just pretty likely. There's a 95% chance that if we take a sample, it'll be within these two boundaries. But that suggests there's a 5% chance that it won't. So, depending on our x bar, our interval, our width of our interval is going to be the same, no matter what x bar value we get. And we don't actually know what the mu is. We just know what our x bar is. And so we calculate our x bar, we compute the interval estimate that goes around the x bar, and then we're hoping that we didn't get unlucky and the actual population mean is somewhere within this interval. So in the example here, this first one right here, x bar is here, our interval limits are out here, and it turns out that the population mean is about halfway between the left border and the middle. Now, in this case, the second example, we got a really big sample average. X bar is really large. And in fact, we're almost outside of the 95th percentile mark. And so the population mean is barely inside the border. But it is. It's still inside the border. That's all we promised. We never said it was going to be close to the middle. It's just in the interval somewhere. We were right. Or if our X bar is beyond the cutoffs of our boundary here, computing it from the population average, if we are more than z alpha over 2 times sigma x bar from the mean, the true population mean, then our interval will not contain mu. And this will happen alpha percent of the time. You will get intervals that are not containing the population parameter. It's going to happen. But we can limit that risk by keeping a reasonable alpha value. So that is all we have time for. We can pick up here on Monday. So remember, I'm not sure I reminded you of this. Remember that, let me pull the announcements back up. Remember that we have Chapter 8 vocabulary quiz next week. Chapter 7 mind tap homework will be due. Of course, you are currently unable to access that. Many of you are unable to access that. So you can start working on Chapter 8 vocab quizzes. Not if you're using the ebook online, can you? Did I post? I made a mistake. Okay, well, just kind of be aware of those two things that are coming up, your vocab quiz and your mind tap assignment. I recognize that you don't have the resources to do those right now. I will get them to you as soon as I can, hopefully like today. I was not planning to because it should be just included in mind tap. However, You don't have that right now, which is its own problem. So if it's going to take me a while to get you MindTap access, then I will post the word separately. Hopefully I will know that quite soon. I don't know if you can click on free trial on the left side and get it to renew. I will send an email to our representative and I will find out. I don't know exactly how that's supposed to work. It may be that they will go into my shell, go into my course, and they will hit a refresh button, so to speak, and all of your trials will refresh. I don't know. I'll have to ask. So I will get on that this afternoon, and hopefully I'll let you know before the end of the day. But I will be at the mercy of the representative, unfortunately. So I'll let you know about that. When is test 3? Test 3 will be at the beginning of finals week, somewhere around Tuesday, Wednesday. And then if you want to take a final exam, that's the fourth exam. It's the optional exam that can replace one of your other 3 exams. Then that will be available to you later on in the week, probably around Friday or so. So that way you can focus on your first exam, meaning the third exam, exam 3, and you can see how that goes, and then you can decide to take the final exam if you want to. So I'll get you more details on that as we get closer. Of course, that's going to be a little ways away. That's, about 2 weeks exactly, actually. So. Okay, Bart, have not been able to find your Quiz 6 feedback. I will see if I can find it. I'm going to go ahead and cut the recording, so if you're watching on YouTube, that's all for today. Catch you on the next one.